Hi, so in today's video we are going to be doing integration by parts. So before we get started, let's first take a look at the formula that you definitely want to know when it comes to integration by parts. But before I do that, let's first go back to what we already know. So here we see that we're trying to integrate two functions that are multiplying each other. And this reminds us of something, right? It reminds us of when we try to derive a product. And remember, to get the derivative of a product, we have f of x times g of x. The derivative of that, remember, is f prime of x, right, times g of x plus g prime of x times f of x. Or some people like to remember it by, you have u times v, and the derivative of that is u prime v plus v prime u, which is exactly the same as these two are the same thing. So we know how to derive a product, but how do we integrate it? So in today's video, that's what we are going to be doing. So when we have two functions f of x times g of x, what we want to do is we want to assign one function to be u and the other as dv. Or we could do the other way around. We could assign g of x as u and f of x as dv. And then once we do that, we get u times v minus the integral of v du. Now I know this is really confusing, so let's try to do a problem. So for our first one, we have x times e of x. So we can already see we have two functions. We have x and we have e of x. So what we want to do is we want to assign u, and we also want to assign dv. You see? U and dv. That's what we're trying to do. Now, we want to know what we want u as. Do we want u as x, or do we want u as e of x? So the whole process of integration by parts is to simplify our integration, is to make it easier for us to integrate. So when we set u and dv, we want to make something that's easy to derive and easy to integrate, especially integrating, because when we assign u and dv, we also want to find what is the derivative of u. We want du, and we want to find out what v is, so we were trying to derive whatever is in here. Integrate whatever is in here. So for example, let's say I want u to be equal to e of x, du would be e of x dx. If I want dv to be equal to, so in this case, since we got e of x, that means dv is x dx, right? So if we do that, we integrate it, right? To get v, we have to integrate x, which is just x to the power of 2 over 2, and we can do plus c, but in this case, it doesn't really matter. So if we do that, what we get is so if we use this formula, what we want to do is we want to multiply u and v. So u and v multiplied, so we have 1 over 2x squared times e to the power of x minus the integral of v du, which is this section here. So we have 1 over 2x squared times e to the power of x dx. But here we can see that we actually made it from here to here. We actually made it even more complicated. That's not what we're trying to do. So this is something that we have to be aware of when assigning our values. So we want to try to make it easier for us to integrate rather than make it harder. So just now we had u equals to e to the power of x, and that made it harder. So that means we want u to be equal to x, so it's easier. So du is going to be just 1 dx, much more easier. And then for dv, we're going to make it equal to e to the power of x, and to integrate that, to get v, we have to integrate that, and the integration of e of x is just ex, right? So we can see that it's much simpler now. Now let's try to apply that process again. So we have u times v, right? Maybe I can just make it easier, highlight that. Yes. So we have u times v, so x times e to the power of x minus the integral of v du. So we have v is e of x, du is just dx, So now we can see it's much more easier to integrate, especially this part. So we simplify our answer, we get x times e to the power of x minus e to the power of x plus c. And that's literally our answer. So for this first one, it's not too complicated. What I was trying to show is just being aware of what to put in as u and dv, especially for dv, because when you integrate something, you want to have a simpler answer. Okay, so now let's try something a little bit harder, but again, the idea is the same. We're using the formula. So this time we have a fraction. So what we want to do is we want to make it into a product. So if we make it into a product, this is basically the same as ln of 3x times x to the power of negative 2 dx. So now that we have that, again, we want to assign what u is, we want to assign what dv is, we want to get du, and we want to get v. So this template here, we use it every time when we do integration by parts. So now let's see, what is easier to integrate? So we don't really know how to integrate ln, right? So that means we want to make that as our u, because ln of 3x, we don't know what the integration of that is. So I let u equals to ln of 3x, and du would then be equal to 1 over 3x, right, times the derivative of the inside function, remember chain rule, which is basically just 1 over x dx. So that means our dv is going to be equal to x to the power of negative 2. So then v would then be equal to the integral of x to the power of negative 2, which is negative x to the power of negative 1, which is basically the same as negative 1 over x. So now that we have that, again, we want to use our formula. So let me just highlight this so it's easier. So we have u times v, so we have u times v, so we have ln of 3x times negative 1 over x. And once you get used to it, you'll be able to make it much more nice looking rather than just writing it up like that. And it's fine for this time, but anyway, so we have that minus the integral of v du, the green section. So we have integral of v, which is negative 1 over x, times 1 over x dx. And just to make things easier, I'm just going to rewrite this so it's easier to look at. So yeah, now that we have that, we can integrate this. And remember, when we have 1 over x squared, that's basically the same as negative x to the power, not negative x, x to the power of negative 2 dx. So our final answer, when we integrate this, we get x to the power of negative 1, right? Negative x. So just to make that easier, basically it's just negative 1 over x. And there you have it. Finally, let's move on to our last problem, which is even more complicated. We have trig. But again, the idea remains the same. We want to find out what u is, what dv is, what du is, what v is. So here we have e of x and cosine of x. So honestly, putting in both is fine, because let's say if I put ex here and cosine of x here, my v is gonna be, sine in some way, and then if I do the other way, if I do the other method, if I do here cosine x and e of x is still going to be e of x, and cosine x will always change. So it doesn't really matter in this case, but I'll just do u equals to e of x. So in this case, if I have e of x, then du is obviously still e of x. then dv in our case is going to be cosine x dx, and we integrate cosine, we get sine. Because if we derive sine, right, v equals to sine, then dv over dx is going to be cosine. So now that we have that, we are going to again make use of our formula. So u times v times the derivative of v du. Just scrolling up for your reference. So we have e to the power of x times sine x minus the integral of, so the order really doesn't matter, I'm just basically multiplying them, right? So now that we have that, we can see that we didn't really make it easier. So in this case, what we want to do is not give up. Definitely don't give up. What we want to do is we want to integrate that again. We want to do integration by parts again. So let's just focus on this here. We have e to the power of x times sine x dx. So we want to do this process again. We want to integrate it by part. So let me just rewrite all this here. So here, again, we want to set u and dv because this is a product. So we're doing integration by parts again. So one thing I want to definitely do is, because earlier I set u as equal to e of x, I want to do that again. So in this case, because I let u equal to e of x and dv equals to cosine x, I have to let u equal to e of x. So u equals to e of x, du is equal to e of x dx, dv is equal to sine of x, and to get v we have to integrate it, so we get cosine x, negative cosine x, sorry. So now that we have that, again, we do the process. Again, I'm sure by now you are much more familiar. A lot of these are just really practice sometimes. So yes, continuing on, the integration of ex times sine x dx is going to be equal to negative ex times cosine x minus the integral. In this case, we're adding because we have the negative sign here, so e of x times cosine of x dx. So now we see that our answer is the same as the problem itself. So this is good because once we've done that, what we want to do is put it back into the entire equation. So all this is equal to this, which is equal to this, and we want to put it back into here. So let's write the whole thing out. So first I'm gonna put this whole thing down here, which is we have e of x times sine x minus the integral of ex times sine x dx, which is equal to this whole thing up here, negative e of x times cosine of x plus integral of ex cosine x dx. So just to make this whole thing easier, let's remove the brackets. We get e of x sine x plus e of x cosine x minus integral of ex times cosine x dx. So now that we have that, what we want to do is we want to put the question back, because this whole thing, this entire thing is equal to the question itself, e of x cosine of x dx. So we're basically writing this whole thing and set it equals to that, because the whole question is this, and we have two integrals that are the same. So what we want to do is we want to basically algebraically put them on one side, so then we can solve for the other side. So in this situation, I'm going to move this to the other side. So in this case, I have e to the power x cosine x dx, and if I move this to the other side, I add it because it's negative, so I have to add it. So plus ex cosine x dx equals to here, ex sine x plus ex cosine x. So notice this we can add up to like terms, which is just 2 times ex cosine x. So really you can pretend it as like trying to solve a function. Like let's say you set this as y or something, and then you just solve for it. Like this is something similar that we're doing. So we have 2 times integral of ex cosine dx equal to, I'm just rewriting it, and what we want to do is we want to isolate this integral here, because that is exactly what we're trying to solve. So to get this by itself, we divide both sides by 2. So we divide it by 2, and we have our answer. So the integral of e of x cosine x dx is equal to e of x sine x plus e of x cosine x divided by 2. And there you have it. That's the end of this video. I hope you all learned something meaningful, how to integrate by parts. Just remember the formula, it's very important. And one big tip is know what to put as u and what to put as dv, because the purpose of integration by parts is to make it so that we integrate easier. So try to do things that will make things easier for you instead of harder. Thank you for watching. I'll see you guys next time.